my great privilege right now to introduce Dr. Melissa Hinten. I first came to know about her from students of mine who said, for Science Forum, you've really got to bring in Dr. Melissa Hinten. So I was very grateful that she accepted. She's an Oklahoman from the northwest part of the state. She went to Oklahoma State University for her bachelor's degree in biological science, then continued on for her master's degree and her doctorate at the University of Oklahoma, with initially emphasis in botany and geography, and then for her doctorate in geography and environmental sustainability. She has taught in Oklahoma at high schools, at a high school. Also, she has taught college classes at University of Oklahoma, Oklahoma City University, University of Central Oklahoma, Oklahoma City Community College, and when she came here, initially Pellissippi State. She became a lecturer in the Department of Geography here in 2014, and very quickly they realized that this was a very special person because they made her in 2017 the director of the sustainability program, and that's what she's going to be talking to us today about. And so we welcome Dr. Melissa Hinten talking about solving the world's wicked problems through local sustainability initiatives.
Well, thank you very much. I'm really grateful for Dr. Lippman for asking me to come and share a little bit about sustainability at UT. So I wanted to craft this talk, to give you an idea about what sustainability is, but selfishly to promote the sustainability program at UT as well. So what the title I picked is, has anybody ever heard of the idea of wicked problems before? Okay, so we'll talk a little bit about what that means. But when we talk, there's other wicked problems in the world, but sustainability problems tend to fall in the category of wicked problems. And so I thought that was a really kind of interesting title that I wanted to go with. So like I said, I work in the Department of Geography. That's where I teach, and I manage and direct the sustainability academic program. I'll talk about in a little bit, there is a sustainability office on campus, is in facility services, and we collaborate with them, but I represent the academic side. So a lot of people don't know, like, what is sustainability? So sustainability is trying to understand the interconnections between these three really big ideas. When we, standing in the light, I'll get over here. I imagine that when people hear the word sustainability, they think about the environment. So environmental sustainability is very prominent, and that's one aspect of sustainability. But sustainability is very holistic, and it takes a systems approach. So it's trying to understand these really big systems, right? So the environment, it's kind of fuzzy. There's lots of systems within the environment. We also need to understand how society fits in, and then the economy. And right, the economy really is part of society. But for our purposes, we usually kind of separate them out. We call this the 3 pillars of sustainability. And when I have students come in and they're like, I want to study sustainability, I usually start off saying, like, okay, so this is what sustainability is. You have the environment, but you can't leave out the society, and you can't leave out the economy either. They're all very closely related when we start talking about the issues. So sustainability is really very issues driven. And so what I want you guys to do, just for a second, you can either chat with your neighbor or just brainstorm in your head. What are some issues you can think about that connects all 3 of these?
Cost.
Huh?
Cost, because if it's going to be costly to be careful with the environment, it might hurt the economy.
Okay, so cost, what else? What's an issue that's connecting all of it? Yeah.
Balance.
Okay, yeah, balance. And a lot of times you'll see this diagram and they talk about if we, as 7.7 counting billion people, are going to survive on the planet, we have to have a balance. We have to live in this space. Yeah.
Technology, what's available right now, what might be available in 18 months,
Yes.
past technology that's no longer applicable.
Yeah, and I think I could teach like a whole, or I would want to even set on a whole class about sustainability and technology. So how do we solve these problems using technology? Anybody else? Yeah. Poverty, very good. And so a lot of times I think poverty. A lot of times I think, and that's such a great idea because we think about the environment and sometimes we think about, and I'll talk about some of these issues, so pollution, loss of biodiversity, loss of fertile soil, air pollution, but we don't think about how poverty is tied into that, and that's a really key point. And so I won't talk a lot about the social side today, just a little bit, but that's something to kind of keep in mind is this idea of the 3 pillars. And so how are these issues and solutions all connected? So that's what we'll see in a second makes some kind of wicked problems because these problems that we'll see kind of weave throughout. We have an issue, and then to have these solutions, we need to think about all of these areas as well. Okay, so what are wicked problems? Wicked problems are difficult to define, do not have clear solutions, have multiple causes, and are symptoms of other problems. And so poverty was a great example, and any of the other ones maybe you had in your mind, and I'll give you some to think about in a second, that we talk about and we deal with in sustainability. It's really difficult to understand the boundaries, like where did this solution or where did this issue start? How are we going to solve it? Who are the key players? And a lot of our issues now are global, and so then they cross all sorts of boundaries, right? So scale becomes an issue. Usually there's a lot of uncertainty associated with it, and they're very complex. And so uncertainty means that if you have, we talk a lot about how issues are not linear. So we can't say this is going to cause this is going to solve this, right? There's a lot of uncertainty. I don't know if this solution is going to fix this problem. I'm not certain. There's maybe not enough data out there. Or there's so many systems involved in this that the uncertainty is really kind of built in. And we'll talk about some examples in a minute. So how do the issues that we just kind of thought about fit in this idea of being wicked problems? Right, so how are we going to find solutions to these issues, these really big issues? And that's where the idea of the wicked problems comes from. Okay, so I'm going to provide a framework to kind of explore these wicked problems. And I'm going to let you look at it for a second, and I'm going to explain it. So this is a framework to try to understand some of our big wicked problems. And it's also a nice model because it looks like the Earth, right? So it's circular. There are 9 of these planetary boundaries that scientists have identified. So let's start here. We have freshwater use, biochemical flows, ocean acidification, atmosphere aerosol loading, so we can think of air pollution, ozone depletion, this novel entities, things that we don't know are going to occur, but we need to start thinking about them. Climate change, the biosphere integrity, so genetic diversity. Yes?
You know, it seems to me like the thing that just affects them the most is when we have a war.
Yeah.
Because that just turns everything upside down.
Having a war. Well, yeah, I mean, the whole like geopolitics involved with, and so what this is showing you, this is just a model saying an idealized of the world. And there's models of this for each country. So you can see which country is pushing the boundaries for freshwater use. And we were just talking about a lot of arid countries in Southwest Asia that have a lot of freshwater issues. So they're pushing that boundary, where we maybe don't have that in the southeastern part of the US. So what this is showing you, looking at these 9 big issues, when it's in the red, it's saying we as a society are pushing that boundary. We're getting into an unsafe space. And then this is saying it's safe. So we're doing okay. We can live, right? Humanity's going to survive. We can live within that safe space for ocean acidification maybe, or ozone depletion. Ozone depletion we've done really well on. We're healing our ozone layer because we've banned CFCs. So that's a wicked problem we've solved. Good for us, pat on the back. But we have some here, and just to point out, so what does this mean, biochemical flows, nitrogen and phosphorus? Where do we use a lot of nitrogen and phosphorus?
Fertilizer runoff.
Yeah, fertilizer runoff. So this is saying we are pushing the boundary. We're getting to the point, you've heard probably the word like tipping point. Are we getting to the point where it's unsustainable? We've got to move back to this safe operating space. And so that is what this kind of framework that I'm going to talk to us about, just to kind of give us a mental picture of what we're saying and what we're looking at. But sustainability is a science, and so we need to think about how are we going to measure this, right? We're scientists, we got to measure everything. And so pointing out this one just because it's the top, and I'm going to talk a little bit about greenhouse gases in a minute. So how do we measure, I'm going to go back again. So climate change. How are we measuring climate change here? So if a scientist wants to talk to another scientist and was like, we're pushing this boundary on climate change, we needed something to measure so we can have a benchmark or a goal to get to. So we know a lot of times what they talk about is CO2 emissions. So you get a measurement of CO2 emissions. And what this is showing you from this paper is they got CO2 emissions from 145 countries. And the boundary that we need to stay under is 2 degrees Celsius warming. If we go over that, we're getting in an unsafe space. And this is saying per capita, we could each produce 1.6 tons of carbon per year. And how many countries are actually in the safe space? So 34% of the countries are in the safe space. That means, right, 2/3 of all the countries in the world are over that boundary. So that's a wicked problem that we have to deal with. And so thinking about where are emissions coming from, let's go back to those 3 areas. We have society, we have economy, we have the environment. Where are a lot of our emissions coming from? Yeah.
Industrialization.
Yeah, so industry, and it tends to be there's a correlation. The more industrialized a country gets, the more CO2 it produces, which makes sense, right? Yeah.
Automobiles?
Yep. So automobiles, transportation's a big one. Anywhere else you can think of?
Livestock.
Yep, livestock.
China and India seem to really influence the environment negatively.
Yeah, so China and India, those are big countries that are becoming industrialized, and so they're producing a lot of CO2. So if we looked at their model of the planetary boundaries, you would see that they're really transgressing some of those.
One question about this slide and the previous one. How many of these issues are local and really are localized, because global warming is global warming. And if we have air pollution problem in Knoxville, or let's say Los Angeles or Phoenix, that's sort of local, but how does that spread?
Yeah, absolutely. And so that's why I kind of want to talk to you globally, and then I want to funnel it down to locally, because that's the whole point. What can we do with this big, okay, so 145 countries, 2/3 of them are transgressing the boundaries. Well, what can we do in Knoxville? Like, we need to know what our emissions are here and how can we change our emissions here. I can't control what's going on in India and China, but maybe we can reduce our emissions here. And then it will, right, be part of the global system, hopefully. Okay, so 2 things I wanted to kind of like, more frameworks to talk about, but we have to have goals. So part of sustainability, and what makes it a little bit different about other traditional natural sciences, physical sciences, and it also makes people a little itchy, squitchy about it, is that we have goals in sustainability, right? We want to get to that safe operating space, or we want to reduce our emissions, we want to increase biodiversity, or we want to protect biodiversity. So when Dr. Littman was talking about, you're going to have a speaker that's trying to protect salamanders because they're being infected by a fungus, that's decreasing biodiversity. We're losing a lot of species. And so we have a goal that we say we want to protect these species, right? So we have goals. And one of the big ones is we want to meet our needs but we can't do it while compromising the biophysical environment we live in, or the planet systems. And then we also have to have data. So we are a science, we've got goals, but we're a science, so we need data. And this comes from this paper. Basically, it was the first one to kind of say sustainability is a science, you have to have these parameters. Sustainability science is going to have to use novel techniques, will have to be extended or invented. So we may have to come up with new models to explain these big, wicked problems. And if you'll notice, this was just 2001, so it's a pretty new field because we're just now, right, our economies are growing, we're becoming industrialized, we're just now seeing these really big issues come out in the past 30, 40 years. So we've got to find a way to deal with them. Okay, so now I want to bring you, we talked about these big global frameworks. So we've got wicked problems. We can understand them through this idea of planetary boundaries. We've got to have goals, but we need to collect some data. So what can we do in Knoxville to help solve some of these problems? So my purview and what I'm starting to do research on is education. So I'm interested in the scholarship of teaching and learning. So how can I help to educate my students to solve some of these wicked problems? And so that's what I want to talk about for the rest of our time, is looking at a few case studies of things that my students have done within Knoxville. So to kind of give you some idea, I'm not going to tell you, I'm not here to preach to you and tell you how to be sustainable, but I want to give you kind of a little taste of some of the initiatives going on in our community to help become more sustainable, to help keep us in that safe operating space. So this is a image of the UT Compost Center. And did anybody know, do you guys know that we compost at UT? So there's composting at some of the dining halls, and not everywhere is composting, but if you notice the trash cans, they'll have recycling options. It would be really cool if there was compost everywhere. Does anybody compost at home? Yeah, some composters. Composting is great. We're making soil. So this is showing you a large pile of compost that was created at the UT Compost Center. And this was last year's Zero Waste Coordinator, Austin. And these were some of my students that we took out to a field trip. So every spring we take a it's a mini field trip. We just go for a morning to look at the compost that can be created. And so a lot of students, I think, are really kind of amazed that they can see the trash that they're throwing away in the dining hall turned into soil. And as we were there last year, one of the students in my sustainability class, her job was also the compost coordinator. And so she drove the truck that picks up the compost from the dining facilities. And as we were out there, she drove her truck up and dumped it out. So it's kind of nice to see other students like being involved in what can be kind of a dirty job, if you will.
Is
So,
it located on campus somewhere? Or?
Yes. No, it is located by the medical center. So if you're driving to the medical center and then, I think, can we tell the location of it? Okay.
It's off the Cherokee Trail.
Yeah, it's off Cherokee Trail. So Carolyn back here, she's the Office of Sustainability Coordinator, so she's got all sorts of great
Is it
info.
up near the body farm?
No, so if you're going to the hospital, it's like this little tiny just
Right when you get
road.
off Pearl Highway, you turn right, and then it's like the first right off of
Across from the duck pond?
I know where you're
that.
talking about.
Maybe, yeah.
Where the fountain is.
You have a very large fly.
Oh, thank you. So this large fly, I'm actually seeing it land on everybody. It's like going around.
Do you mind if I catch him next time and carry him
You can
outside?
carry him out. Yeah, we were just talking about not killing our biodiversity in here. It's like 2 species now.
If we take our compost items and feed them to the local wild animals, is that okay?
I don't think so. No. You should just compost it.
Well, I don't have much. I give it to the squirrels and the raccoons.
I don't think so. I would say no. Because then you're just bringing the raccoons into the city.
It's just little bits. It's
Yeah.
like a handful once a week.
Well, what's kind of interesting at this compost site is that you can see when they dump the truck. So there's also paper goods in there. A lot of it comes from pre-consumed food, so in the dining hall when they're chopping vegetables, instead of throwing it away, like the end of the broccoli, they can compost it. And then they also have some post-consumer food. Which are the locations of the post-consumer food? Do you remember? Put you on the spot.
Well, all the PCB and Stokely collect it. You just don't see it because it's behind the scenes. And then all the dining locations do, but some of them it's just not, like, you don't see.
Yeah. So, yeah, I was going to say, there's something else cool about that. Collecting the compost. Okay, well, I can't think of what else. I'll move on. Oh, and it's used locally on campus in beds and on the organic farm. They use, so it's a really nice kind of closed system where we're taking our waste, producing soil, and then reusing it on campus. So it saves money. We don't have to buy compost or mulch, and then it's reducing emissions because we're not sending that to a landfill to start decomposing and producing methane. So it's a really nice way to hit that triple bottom line, or that the 3 pillars of sustainability. Okay, so what are some projects I want to talk to you all about that my students have worked on over the past couple of years? So the 2 broad areas I want to talk about is called engaged learning. So engaged learning, hopefully we're having a little bit of engaged learning in the UT Science Forum. So instead of me just passively giving you knowledge, you're engaged in the process. So I try to get my students engaged in processes of learning. And so this one is a capstone project that seniors in sustainability work on. They are required to create a greenhouse gas inventory. And I'm going to stop for a second to show you, this is an infographic of the US EPA's greenhouse gas inventory. So we're inventorying, we're making measurements, a list of the greenhouse gases produced. And so we can see where we have fluorinated gases, nitrous oxide, methane, but our biggest one is carbon dioxide. And then the sectors, which when I ask you guys where is our CO2 coming from, you basically nailed it. Transportation, we get some from electricity, right, if we're burning coal or natural gas. Industry, agriculture, commercial, residential. So really not even a lot, like residential is not a big one. So this is where a lot of our greenhouse gases are coming from. So students, right, this is for the US, the students had to pick, well, let me go back, either UT campus, Knoxville, or Knox County, right, those are 2 separate municipalities, to do a greenhouse gas inventory for. And they got to pick a sector, so these are different sectors, either transportation, electricity, and we'll show in just a second this kind of mix of agriculture, commercial to look at. Yeah?
Seems like we should add a column for the fact that we are deforestation so
Yes,
much.
that's what I'm going to talk about.
Oh,
No, perfect. I'm so glad you picked it out. So he said we need a column for deforestation, and that's what it's missing. And the reason it's missing is because it's really a wicked problem. It's difficult to measure deforestation, but I had some students that did it for Knox County, and I was very proud of them. And that's what I'm going to show you next. So they did this by mapping land cover in Knox County. And then I had another group I want to talk about. They mapped bike sharing and determined the carbon emissions saved from people biking as opposed to driving. Excuse me. Okay, so this is a group of 3 students, and they created land cover maps in Knox County. And I realize this is fuzzy and hard to see. So Knox County, the yellow is 2001 was cropland, and really hard to see, but there is some forest in there. And they, this was a data set that really, it's freely available for everyone. And it's a land cover data set that the US Geologic Survey produces. But what the students did is they classified it. They basically said these pixels are forest, these pixels are cropland, and they did that for 2001. And then they saw how that land cover changed in 2011. And that was because that was the most recent year they could get, right? Obviously that's 8 years old now, but that's the most recent they could get.
would you like us to dim the front lights for a minute?
Sure. And so even though you can't see it, there are categories of wetlands, open water a little bit. But most striking that you can kind of see is what is the biggest change in the land cover? Yeah, so we're going from cropland to a lot of settlements. Maybe a loss of forest cover too. Which I think we probably all have seen this on the landscape. When you get outside of Knoxville into the suburban areas, where are new housing developments going up? Right, it's farms usually that are selling to developers. And then it's becoming a housing development. So what the students wanted to do, and what he right on picked up, is we need to understand how emissions are changing based on this landscape change. So if we lose forests, how is that affecting our emissions? If we lose cropland, how is that affecting our emissions? Because we know plants, what do plants like to take in? CO2, and what do they give us? Oxygen and wood, carbohydrates, whatever, if we're eating it, if we're eating crops. So we like to have the forest around, we like to have the croplands, we like to have the grasslands around, but as they're changed, it's changing that emissions. And this is what they found, and that was so cool. So here is the graph of that map we looked at. Let's look at that first. So we can see that we lost a lot of forest land and we lost a lot of cropland, and we gained a lot of settlements. Right, Knoxville's growing. But correlating with that is we lost the capacity to hold a lot of carbon in that forest and in that cropland. Sorry, this isn't labeled well, but it's the same categories. Interesting enough, you actually do get a little bit of carbon sequestration from settlements, but we lost a lot. So that's the takeaway here, is that sector that's missing in the US EPA greenhouse gas emissions is, well, what's happening with this area, right? They talked about electricity, they talked about transportation, they talked about residential, but there's a lot of stuff going on with the changes in our landscape. And that's a really big area of a lot of research needs to be done. And it hasn't been at this point just because it's kind of tricky. Yeah?
So for the settlement part of it, are they like including population rise, like just general more like emissions being produced by like more people?
No, this is just land area.
Okay.
This is so, and the really neato thing, but I was so impressed. These students, so you can calculate the carbon dioxide from driving your car or from riding a bike, and I'll show you that in a second. But there's no just clear calculation to calculate how much this forest is sequestering or how much cropland. What they did is they took the different tree types in Knoxville and they calculated for each of the different tree types and aggregated it. It was really fascinating. And so they, for this specific area in Knox County, determined how much that we're going to lose based on losing these forests. Yeah.
How does settlement sequester carbon?
I don't know. I need to ask you. I think it must be lawns. That would be my guess. There's something interesting going on here that there's a little bit of a gain.
Houses built with wood.
Yeah. So maybe that's the houses are built with wood. I don't have a good question for you or answer. Sorry about that. Okay. So the next one. Make sure I'm got some time. Anybody have any other questions about this? And I'll come back to it in just a second about like future research that needs to be done. So the next group looked at reducing our emissions with bikes and riding bikes. So bikes are good for reducing emissions. They're also good for our cardiovascular system and building community. So hitting those three big areas. Yeah, that would be great. I don't think you'll fall asleep if they're off. I teach with lights on because I'm always afraid they're going to fall asleep. So a little bit about the bike share program. I don't know if you guys have seen it. It's called Pace Bike Share in Knoxville. Okay, you've seen them around. So Visit Knoxville put a lot of money into bringing it here, and then on campus, the Office of Sustainability, and this is their logo, Make Orange Green, also helped to make that happen. So what one group of students did is they got data from Pace Bike Share, and it was the data from February through October. And this part of their assignment is they have to determine emissions and then do some sort of mapping project. So they determined between February and October that 44,000 miles were ridden on the bikes, and the average trip distance is about 2.7 miles, so not a huge amount ridden. And they estimated that it eliminated 4,200 car trips, which ended up equating to approximately 6 tons of carbon. So if you remember, we're supposed to be staying under like 1.6 tons of carbon per year. So 6 people, this is 6 people's emissions. That's pretty good, right? I think, maybe. But what they did is they took this kind of activity data, is what it's called, and then there's calculations, there's equations that you can basically plug in the numbers, and it will give you the amount of carbon that's sequestered. So that's how they determined that in this time period, so not even a full year, that Pace is doing a good job of sequestering or eliminating, 6 tons of carbon just by people riding bikes. And then they took the data. So when you rent the bike, you get a point taken, right? You put it in your phone with the app that you're checking out the bike, and then you check the bike back in. And so Pace collects all of that data. Big data, right? There's data everywhere. So what they did is, this is actually a Google map, and they took the data and overlaid it with Google Maps, so you can see all of the different, although it doesn't show you the distance there, it just shows you kind of the pickup and drop off. And these are the locations where you can store the bikes. But what they did with this, and they ended up making, it's called a heat map, so you can see the kind of density. A lot of it, you notice, is around UT campus. And then there was some over here, so there's the Gay Street Bridge is where most people are riding the bikes. What they were wanting to get at was to see if, is it feasible to get it farther out to get more people to use it. So it's nice that a lot of people around campus are using it, but they wanted to see, is it gonna be more accessible for people that really rely on bikes to use? And I don't think that they found that data yet. Okay, so further research for this is there is a lack of a greenhouse gas inventory for Knox County. So Knoxville, the city of Knoxville, calculates for all of those different sectors. There's a Office of Sustainability, but for Knox County, outside of the city proper, there's a large void in the data. And so what we plan to do is, for the capstone class that's coming fall, is that we are going to break that up and calculate the emissions for Knox County, and then work with the city of Knoxville. So the idea is, we don't know. You would assume maybe the emissions are lower in the county because there's less people maybe driving cars, there's less settlement, there's less industry, but we don't know. Because we just saw that the change in that forest cover to settlement changes a lot of the carbon sequestration. Yeah?
How do you gather that data? Do you look through records that companies provide,
Yeah.
or what?
Yeah, so this falls a little bit under, it's called carbon accounting. And there's a lot of accounting standards, which I realize you're like, you guys are talking science, and now I'm throwing in accounting. But it's basically, you try to get as transparent data as you can get, the most reliable data you can get. And some of it comes from companies, some of it comes from municipalities. Some of it, like my students calculated, if we remove this tree type with a settlement, how much carbon am I losing? So it's essentially aggregating large data sets to try to understand this. And so our plan is, this is a nonprofit's International Council for Local Environmental Initiatives, and they have a data set where we can basically they have all the equations built in to this platform that we can use it. And what they don't have, though, is that land use change, and they're working on it right now. And they want to work with UT to work on it. The guy that works for ICLEI, he is a graduate from UT. And so I got in contact with him and he's like, oh, I'm a graduate. I want to work with you on this. So I think we're going to start a process talking this summer. And then it may turn into a little bit longer of a research project, but I at least like for my capstone class to start on it in the fall. Any questions? All right, just a couple more minutes. And so another example of engaged learning that I want to share with you, this is my kind of feel-good stuff that I really like. And I'm torturing Rachel with it this semester. So she's in my sustainability service learning class. So they have to complete service learning hours. And so students engage in these opportunities, but they have to reflect upon it. So that's what service learning is. It's community service, but the learning part is they have to think about why they're doing these projects. So they have to reflect on how is the community benefiting and how are they benefiting by doing this. So these two students, this is Hal and Nate last year. This is the winter farmers market. So they volunteered to help out. They collected data, you can see there's the iPad, at the winter farmers market last year.
Where is it?
That is at the Central Methodist Church on like every other Saturday in the winter from February to April. And then, in April it moves down to Market Square. So they complete service hours as part of their class assignments. And, okay, I guess that's the end of that one. So Nourish Knoxville is what it's called. And then another example, this is Katie, and she volunteered at Century Harvest Farms. And so some of the things she's learning is food security. So the more local food we can produce, it makes our communities more resilient, meaning if there's big shocks to the system, our food's locally grown. We know the people, we know the farmers that are growing our food. Right, so think about those three pillars. We're talking about our economy now, we're talking about our society, but then the environmental part, how does this fit in those planetary boundaries? We're reducing emissions because we're growing our food locally. We're probably reducing water runoff because it's a small local farm that's using organic methods, maybe using less fertilizer. So these are the things I want students to think about when they're doing these service learning projects, is how is what they're doing fitting into this big idea of these planetary boundaries. And then, like I said, I'm starting to do research on the Scholarship of Teaching and Learning, so pedagogy. So I'm really excited and I love my students doing these projects and getting out in the community, but is it working? Are they actually learning anything? Or is it just like, I think it is, right? Because I think it's lovely. Well, last year, so the 2018 class, I collected pre and post data on them. So at the beginning of the semester, they completed a questionnaire asking stuff about like lifelong learning, collaboration, real world skills. And then they also completed a post-service learning, the same questionnaire. And the preliminary results we're finding is that there is significance in a lot of those categories just from this one semester of completing service learning. So wrapping up, how will we begin? I don't know that we're going to solve our wicked problems, but how can we begin to solve them? I think that we need to share our knowledge. It's in academic jargon, it's called transdisciplinary inquiry. It basically means the biologist needs to talk to the economist, needs to talk to the teachers, needs to talk to the sociologist, right? How do we solve climate change? We all need to share this information. Communicate or collaborate with our communities, right? So we need to do these local initiatives to solve these big global problems. And to do that, we need to know who our neighbors are and know what their needs are. And then, of course, because this is my shtick I'm giving you, is engaged learning. I think that engaged learning is a really good way to start getting students passionate about sustainability initiatives. And that is all I have. Thank you for your time and listening to me. And if anybody has any questions, I'm happy to answer.
Do you have any comments about scale?
Yes, I do have lots of comments about. So that idea of the planetary boundaries, like if you don't know what those boundaries are at the local scale, we really need to know that to scale it back up to I don't know if that answers your question, but I think that that's the big area of need, is to understand, and that's why I think local initiatives are really important. Yeah.
Some practical questions. Is Knoxville City doing anything to reforest? Are they trying to plant more trees?
Yes. So there is a, what is it? It's the Knoxville Urban Forest. I'm not sure if I'm messing that name up. But yes, they are protecting a lot of forest spaces. And now are they replanting? I don't know, Sam, do you know?
Yeah, Knoxville has an urban forestry program where they're replacing trees in neighborhoods on a very regular basis. It's usually somewhere between 500 and 750 trees a year are getting planted in neighborhoods. So it's a community initiative that the city does in rights of way along street rights of way.
So they're not just replacing, they're
adding.
they're adding.
So the urban forester, he's calculating vacancies. So he'll go around and he'll determine where trees have been, or where he has recently had to take a tree out, and he lists that as a vacancy. And then he fills those areas in as vacancy sites where he can plant a tree. And then as he builds in his planting plan for the calendar year or the fiscal year, he starts adding those sites into where he can plant trees. So he's right now working directly to figure out where he's going to plant trees next year at this time. So he'll be making trips to go buy trees and plant them. That's on an urban forest level. The other side of it is mostly about codes. How do we manage development?
So they would
on a
leave a
city
few trees
scale.
instead of cutting them all
Pardon
down.
me?
So they would leave a few trees as they develop.
And
instead of cutting them
a lot
all
of that will probably have something to do with the READ code.
Yeah.
Knoxville, if you've heard some about that. So read into that, and there should be some information about how things might be changing down the pike regarding codes and building codes and construction development, things like that.
There's also a community group called Trees Knoxville that is having a lot of volunteers participating in tree planting, and you are encouraged to participate yourself. They also have training programs for having that you can learn the skills that you need to plant trees sustainably, so that they will grow and thrive
It's just
rather
little
than
trees also.
die. So a lot of people go to the training also for their own yard, so that they know how to better deal with their own trees.
That program is called the Volunteer Forester Program, and it's held a couple of times a year. And it's a 6 weeks, I think.
Well, it
training
depends
program.
how long, yeah, 3 or 6. And they work with the city forestry too. And,
Yeah, go ahead.
Thought you were looking behind me.
I'm looking at that fly. No.
I don't know if this is something you can answer, but the city encourages us to keep our vegetation trimmed down. When I like to let it grow up. And I don't know how much that contributes to helping with the CO2 problem as compared to trees.
Yeah. Do it. Well, so I actually have a module in one of my classes. I talk about that because, and maybe the carbon isn't that big of an issue, but if you think about, you're reducing probably water runoff when you have more vegetation as opposed to a lawn, and you're not adding pesticides, fertilizer, just mowing the yard with a gas lawnmower. So on a small local scale, right, if we all moved our lawns towards meadows or forests, then it would start to add up. There's
Codes enforcement frowns on me quite a bit.
well, but it depends on your neighborhood. Like my neighborhood, they can't do anything to me, but they'll probably give me some dirty looks. Yeah.
On your wicked problem chart, you had genetic diversity up at the top.
Yes.
What is that?
Almost got it.
That is a great question.
I know, I'm gonna get it.
Yes, that is.
I'm sorry, I'm trying not to hurt
No.
him, I'm just gonna carry him outside.
So his question was asking about this genetic diversity. This has to do with a loss of biodiversity, so extinction of species. So we're losing a lot, going back to when he was talking about the next speaker, talking about the salamanders. So we're losing a lot of amphibians because amphibians are these species that are real like indicators, and they are in both environments. They're land and water, and so they're really getting a brunt of changes in habitat, of any sort of pesticides that are in the water. And so as we lose those species, we're losing genetic diversity. And so that's what that area is right there. It's losing species, yeah.
So I wanted to ask, how much of this can be done without like substantial policy change? Sort of, how much can we really do to be sustainable if other industries and other
Right.
sectors become air polluting more than we can?
So his question is there, how much of this needs to be a policy change? A large part of it. So we were just talking about when we were eating lunch, one of the things I tell students is we all think that we can just buy things that are green and we're gonna save the planet. Us consuming green products isn't gonna make a difference. It's policy, and what I didn't show you, so it has like the 3 pillars. What they talk about is what like kind of underwrites this whole thing is good governance. So it's basically policy, and we'll read an article later in the semester, Rachel, that we talk about. There's this idea of conscious consumption, and there's people who've done studies, and it doesn't make any difference. But what does, so instead of that $30 you'd spend on whatever green product, put that money towards local politicians, essentially. Not that we need to be turned to lobbyists, but how can we form supportive local policies, right, that are serving us? So it really does come down to a lot of policy. Yeah.
What was I going to ask you? Oh, the data on the individual trees. You said they got data to figure out when you remove a certain tree, how much carbon you release or not sequestered. Is that available to the public? Is it put together?
So what he did, he was a brilliant student. He took the data from the Knoxville urban forest, and they've collected data on it. And so like I said, a lot of it is this kind of carbon accounting. And then there was another study that he looked at where they determined by the diameter of breast height, so how big the tree is by these different species, how much carbon is sequestered. So he used that, and he basically, I think, kind of created an equation to determine based on the Knoxville urban forest, and then apply that to how much has changed over time. So no, I don't know if it is, but maybe.
The U.S. Forest Service does a periodic program called the Forest Inventory and Assessment, and recently
That's where I
they've
think
done
he got
one that was urban rural interface, urban forest overlay assessment.
Okay.
So the data should be available through. You can probably contact a local state forester or get in touch with the Forest Service. US
Okay,
Forest
and that's species specific?
Yes, based on the forest cover types that they're aware of in those areas, yeah.
Are you looking to go out in your backyard and see how much carbon you're sequestering?
Well, my wife and I are very interested in this, and we have planted a number of trees on our land, and we're doing other things that we feel we can do on our own level.
Yeah, and I think it will get there, I think, very soon. Like, there's a need to have this data available, right? Because it actually isn't that hard to find out your automobile, how much CO2 you're producing. Like, you can Google that and find it pretty easily. But to understand this kind of information about like moving from forests to settlements or crops to, like, what is this, what damage is actually done? Like, that's the big area that we need to do research on. And we need to make that information publicly available. Yeah.
So if we go back to the policy question, we don't even have agreement on within each one of those categories. Should it be green? Are we in a green, yellow, red?
Right.
And then everybody values each one of those categories differently. And you look at your early chart, 50, 60, 70% of the CO2 is coming from some form of industrial type of thing. Man, nobody wants to stop heating their house.
I know.
Stop driving.
Yeah. That's why it's a wicked problem. Like, it's so complicated. Well, and that goes back to his point about scale. Is like, wait, so this is like this huge global. it needs to come down to the actual political units. When I say unit, I mean like the municipal footprint or the state that can actually implement policies to do something and can set the goals. Like, well, what is our goal for Tennessee, or what is our goal for Knoxville? Yeah.
As long as you've got this chart up, I was flabbergasted that climate change isn't way into the
Right.
and that freshwater use. Georgia was about to attack Tennessee.
I know.
To annex the Tennessee River. The Colorado River ends before it gets to the sea.
Well, and that's what I think is, right, this scale is so coarse because it's the global, but if you looked at one for the US, which is not surprising for us, is that we transgress a lot of boundaries because we live really well, right? We consume a lot. But there's a lot of countries in the world that are not, and so when you take the global average, this is what you get. So there's some countries, so one that we look at in class that we talk about, it shows the US and it shows Sri Lanka. And so Sri Lanka is a developing country. It's a small island, right? Compared to the US, we're very wealthy, very developed. There's 330 million people. We transgress, we push a lot of boundaries compared to these small nations. So it's very important to scale down to what policy can actually be done and what change can actually happen. Yeah.
You had the chart where they took forest and farmland, and now it's subdivisions. Do you know if Knox County is doing anything about, because we see this a lot, empty buildings, empty parking lots, vacant forever, and then the field next door to it, they plow it all down and cut all the trees down and build something new.
Right.
Next to it, and then there's this empty building. Is anybody looking into that? I mean, why does that happen? Because once it's paved, it's paved.
Right.
It never goes back to trees.
I'm imagining it would have to go through that zoning that Sam was talking. So Knoxville is doing a rezoning, which it hasn't been done since like the 60s, I think. So that would be a place to look and see if they're doing it. I mean, it's because it's cheaper to buy farmland, unfortunately, than already developed land, which is really unfortunate. Because we also need farmland. We want people to keep farming. Like, we want our food to be grown locally and to employ people in farming. But yeah, that's my biggest. If I had a superpower, I told my husband my superpower is that I could like just go and I would demolish all those old like abandoned places and turn it into a park.
Yes.
One more question.
How,
Oh, go ahead.
how do we support this local farming?
Have you done like community supported agriculture where you can buy farm shares? So you can pay a farmer up front before the growing season, and then every week they give you a basket of food. And so so the acronym is CSA, but it's community supported agriculture. And a lot of the farmers that are represented at the farmers market, they will also have these farm shares that you can participate in. And it's really nice because it gives the farmers a lot of upfront cash. So I participate in one, and I pay for all of my food for the year up front. So I give the farmer my fee, and then all the 20 families that support that means they get a big influx of cash at the beginning to run their farm. So that's a really nice way to do it as
Maybe
well.
time for one more question.
Okay, sorry.
About this chart, it doesn't actually show how serious these problems are. It shows how high the risk is of our ignorance. So essentially with climate change, we know quite a bit because there's been so much science done on this and data collection. So we know pretty much where the boundaries are, like the 2 degree centigrade that we talked about being a limit where we can't bring it down for
Yeah. So our our uncertainty.
Right.
Good point.
So climate change we know a lot, and freshwater we know a lot, and some of these other things like genetic diversity, we don't really know when it will hit us.
Yes, very good point. Thank you for pointing that out.
Let's all thank Dr. Hinten.
Thank you.